Hey guys, I'm Siddhi. Today we're going to study chapter 2 of Microeconomics, the theory of consumer behavior. Now you have to understand this chapter is absolutely critical for your CUET preparation. Why? Because it's the foundation, the building block for everything related to demand. So let's get right into it and make sure all these concepts are perfectly clear.
So just imagine this. You've got 100 rupees in your pocket. You're feeling hungry, maybe a little thirsty. Do you buy momos? Or a cold drink? Or maybe a little of both? How do you actually make that choice? Well, that simple, everyday decision is exactly what economists call the problem of choice. This whole chapter is about breaking down how you, as a consumer, decide what to buy to get the most satisfaction possible from your limited money. Okay, here's our plan for today. Think of it like we're building a rational buyer's toolkit. First, we'll define the problem. Then, we'll look at two ways to think about satisfaction: cardinal and ordinal analysis. After that, we'll get real with the budget constraint, find the sweet spot for the best choice, and finally, see how it all leads to the big concept of demand. So, at the very heart of consumer theory is this one basic conflict. Our wants? Well, they're unlimited. We always want more. Better food, newer clothes, the latest gadgets. But the money we have to get these things, our income, is limited. It's finite. And that scarcity forces us to make choices. So the goal for any smart, rational consumer is to use that limited income in a way that gives them the absolute maximum satisfaction. All right, let's open up our toolkit. The first tool we're going to look at is called cardinal utility analysis. Now, this approach makes a pretty big assumption. It assumes that we can actually measure our satisfaction, or what economists call utility, in specific numbers. The unit they use is called a util. So, in theory, you could say, wow, this plate of momos gives me exactly 50 utils of happiness. It sounds a bit strange, I know, but it's a really useful way to understand some basic ideas. Now, with this idea of utils, we have to understand two key terms: total utility and marginal utility. Total utility, or TU, is pretty straightforward. It's the total satisfaction you get from consuming everything. So if you eat 3 momos, the TU is your satisfaction from all 3 of them put together. But marginal utility, or MU, is the extra satisfaction you get from consuming just one more unit. It's the boost you got from that third momo specifically. Just remember, MU is all about that one additional unit. Now take a look at this table from your NCRT book. It shows this relationship perfectly. See what's happening? As we go from consuming 1 unit to 5 units, the total utility is going up from 12 to 18 to 22 to 24. But look at how it's going up. The jumps are getting smaller. And that's because the marginal utility, the extra satisfaction from each new unit, is constantly falling from 12 to 6 to 4 and so on. And this observation leads us straight to one of the most fundamental laws in economics, the law of diminishing marginal utility. It's actually super intuitive. Imagine you're really hungry and you start eating pizza slices. That first slice is just amazing, right? Pure bliss. The second one is also really good. But by the 4th or 5th slice, you're getting full. The satisfaction you get from each additional slice keeps getting less and less. That's this law in action. Okay, let's pause and think for a moment. Look back at that table. At the 5th unit, what was the marginal utility? It was 0. So at that exact point, what was happening to the total utility? Well, if you check, the TU was at 24, which was its highest point. This is a relationship you must remember. When marginal utility falls to 0, total utility is at its absolute maximum. This is also known as the point of satiety.
Okay, dhyan do. This is a very common CUET trap. Look at the 6th unit in the table. The MU is -2. Now, does that mean your total satisfaction is negative? No, absolutely not. It just means that eating that 6th unit actually made you feel worse. It reduced your total satisfaction from 24 down to 22. Your total utility is still a positive 22, but the additional utility was negative. Please remember this difference for your exams.
You know, that whole idea of saying something gives you 50 utils is a bit unrealistic. In real life, we don't really think in numbers like that, do we? What we actually do is we rank our preferences. We say things like, I think I'd prefer a cold drink over momos right now. And that's the whole idea behind our second tool, ordinal utility analysis. Here, we don't measure satisfaction, we just rank which combinations of goods we prefer more.
And the main tool we use in ordinal analysis is called the indifference curve. Just picture different combinations or bundles of two things like momos and cold drinks. An indifference curve is a line that connects all the different bundles that give you the exact same level of satisfaction. So whether it's a bundle with 5 momos and 1 cold drink or one with 3 momos and 2 cold drinks, if they're on the same curve, you are equally happy with either. You are literally indifferent between them. Now, there are 4 properties of these curves that you absolutely have to know. First, it slopes down. That's because to get more of one good, you have to give up some of the other to stay at the same satisfaction level. Second, it's convex to the origin. We'll see why in a second. Third, a higher curve is always better because it means you're getting more stuff, so more satisfaction. And finally, 2 curves can never ever cross. That would just not make any logical sense. So what gives the indifference curve its shape? It's something called the marginal rate of substitution, or MRS. The MRS is just the slope of the curve, and what it tells you is the rate at which you are willing to trade one good for another. For example, how many cold drinks are you willing to give up to get just one more momo? And as you get more and more momos, you're willing to give up fewer and fewer cold drinks to get another one. That's why the MRS diminishes, and that's why the curve is convex. So let's connect those dots right now. Pause and think about it. Why is that indifference curve convex? Well, like we just said, it's all because of the diminishing marginal rate of substitution. When you already have a ton of momos, you don't really value the next one that much. But at the same time, you have very few cold drinks, so you value each one a lot. That's why you're only willing to give up a tiny bit of your precious cold drink for one more momo. And here's another CUET trap you need to watch out for. While a normal indifference curve is convex, examiners love to ask about the special cases. So for perfect substitutes, like 2 different brands of the same juice, the IC is a straight downward sloping line. And for perfect complements, like a left shoe and a right shoe, it's L-shaped. You have to know these 3 shapes: convex, straight line, and L-shaped. Okay, so we've spent all this time talking about what a consumer wants, what they prefer, their indifference curves, but that's only half the picture. Now we have to bring in a dose of reality. What can the consumer actually afford? And that, of course, depends on 2 simple things: their income and the price of the goods. This is what we call the budget constraint. So the budget constraint is shown by a graph called the budget line. This line shows you every possible combination of 2 goods that you can buy if you spend your entire income and not a paisa more. The equation is really simple. It just says that the amount you spend on good 1 plus the amount you spend on good 2 has to equal your total income M. Any point on that line is an affordable combination for you. So let's pause and think again. What happens if, let's say, your income goes up, but the prices of goods stay the same? Well, you can now afford to buy more of both goods, can't you? That means your entire budget line is going to shift outwards, to the right, in a parallel way. Your world of affordable choices just got bigger. All right, this is the moment we've been building up to. This is the grand finale. We have the indifference curves, which tell us what the consumer wants, and we have the budget line, which tells us what the consumer can afford. So to find the single best, most optimal choice for the consumer, we're going to bring these 2 tools together. And here it is. The consumer's equilibrium, their optimal choice, is at that one specific point where the budget line just gently touches, or is tangent to, the highest indifference curve that they can possibly reach. It's at this one magical point where what you're willing to trade between goods, your MRS, is perfectly equal to what the market forces you to trade, which is the ratio of their prices. This is super important, so dhyan do. The equilibrium is not where an indifference curve intersects or crosses the budget line. If it crosses, that means there are still other points on your budget line that can get you to an even higher indifference curve, meaning more satisfaction. You can do better. Maximum satisfaction is only, and I mean only, at that single point of tangency. So, you might be wondering, Sivi, why did we go through all of this with the curves and lines? Well, here's the payoff. This entire framework is exactly how we figure out where the demand curve comes from. Just think. What if the price of momos suddenly drops? Your budget line would pivot outwards. This would let you reach a new, higher indifference curve at a new tangent point. If you track all those new equilibrium points as the price changes, you are literally drawing out the demand curve. This is the logic behind the law of demand. Okay, let's do a super quick summary of the whole story. It all starts with one problem: maximizing satisfaction with a limited budget.
The cardinal approach uses the law of diminishing marginal utility to explain this. The ordinal approach uses indifference curves and the MRS. The optimal choice, or equilibrium, is where your budget line is tangent to the highest indifference curve you can afford. And this whole process is what explains why the demand curve slopes downwards. All right, let's wrap up with a quick question to see if you got it. A consumer is in equilibrium. Suddenly, the price of good X falls. What's the immediate effect? Think about it. Your income hasn't changed, and the price of the other good hasn't changed. But you can now afford more of good X. So the budget line will pivot outwards from the Y-axis. The correct answer is B. This pivot is what allows you to reach a new equilibrium on a higher indifference curve. Make sure you practice these kinds of application questions.